Hello everyone, I am Xiao Gang. Okay, in this lesson, we will look at this operator. Let's take a look at this operator. This operator is actually very simple. It's that you instantiate a TMap and then it can copy another TMap because its equal sign has already been overloaded. After overloading, this map is equal to this one. Then you modify one of the elements. So the modification to your new map will not modify the old map, because they are two separate instances. In fact, he has already passed it. The elements inside. Here's a standard value. Through the standard copy constructor, or performing a copy using the copy operator. Because it is deep layer, therefore, it is actually a copy. It is just a new one. It's just that they look the same. And it supports dynamic semantics, meaning you can first copy and then empty it in your hand. But through dynamic semantics, you directly transfer this memory. And the original thing is gone. That's basically what it means. Okay, then we will demonstrate this operator to everyone. Then we will emphasize it again for everyone. Some places might trigger some anomalies. Okay. Similarly, in this place, we first write one called operated. Look at how this word operation is spelled. We will create the implementation of this function. We'll just paste it over simply. We can ignore the stuff in here. We might need to copy this number from the front. Let's change this name. We want to use this K letter. Note that the K value here is 5. It doesn't mean it has an index of 5, meaning it's not the 6th element. So he means the K character. It's the K character. And then remove what is referenced as, remove this element with K character equal to 3. There isn't any now. We can just change this to 1. Similarly, if we modify this host, then I still hope we go. Of course, we won't need this after I modify it. I want to just move the original one over. We can do this. Then let's define another host. Let's call it labmap2, and then it equals multemp. Just move it over. This element count should be cleared, and in order to avoid problems, we will set it to 2 equals 1. Okay, now I'll execute this. It is redefined here. Let's give it a 2. Yes, we will execute this now. Okay, our endpoint has arrived. Good, this is our map, right? No problem. In this area, we make a copy. It's equivalent to 2 maps, right? Although they look the same. And we are now operating on the second map. You will notice that this element number 5, it has already changed from mango2 to map. And then this K character is, note that this is 0, 1, 2, 3. But we are using this one. This is 0, 1, 2, 3. And we brought this one in. This is not the same thing. We use this K character. You must remember this point. The element we removed has a K value of 1. K value is 1. So what was removed is ample. What was removed is ample. Okay, so we find that the ample here is no longer there, right? But actually, it still has it here. It's still here. And then, if we look further along, actually this spot, let's move this friend over. Then it will be empty, just like that. Okay, then take a look at, we removed this area, right? It used to be a 4x4. We removed it. In fact, we clicked on new map. He moved it to this new map. So our first FRED map was cleared. That means 4 formations. We are focusing on new map. We can also see the elements inside it. It has 3 elements. Originally, it had an element called ample, right? It's the sample where K equals 1, right? Let's click down here again. Click, 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 click. Then let's click again. Right, look at this place. There's also one. In wild, you can click again. You will find that the number in this place equals 4. Isn't it amazing? Right. You will find that everything before this place is correct. You can see 750 sec, right? 750. So actually this is the original. Our unique clicked a sample. Actually it is him. It was removed. But actually it is still in the space where this element is located. Still in this spot. just right here. So this spot is 44. This spot is 34. So you need to understand this. We will explain the details to you later. This should be a supplement showing the VS visualization from before. You need to use this generative way to look at the information inside, okay? Then let's just move it over there. After going through it, I'll explain the distinction to you all. We haven't covered smart pointers yet, but we did cover UObject and UActor. For example, if I define a map, the map I defined, giving it an int32, and then we call it actor new, right? Then we show something called myActor. Note this, what we have here is an actor, because we know that it has a prefix, so it is like this. Actually, we can now add several elements. For example, we add the first one. The first one is a reference to ourselves, so we just use this like this. Then the second and third ones. We haven't captured any other objects yet. We need a way to capture objects within the scene, but we don't currently have one. There is only him in our scene, so we first pass it as empty. So we have an array of these actors. Then I define another array called myAnotherActor. More accurately, we call it myAct. Trapped. We explicitly write out the pointer like this. Will you misunderstand the process like this? Okay, then we'll have it wait for this directly. So if I add this location, for example, if I pass a 1 like this, then I let it go side actor location. Right. Okay, so we actually did this. Actually, we did this. All these pointers point to the object of our own actor. This object won't be destroyed just because you copy this pointer or anything else that destroys it. The life cycle of its object follows what's in our level, managing the life cycle of this actor. So what is actually copied here is this pointer. You must note that what is being copied is this pointer. It just means that after copying, there are 2 pointers. You can use the first pointer to access it. It's also okay to control it with just 1 pointer. Right? These are the 2 pointers. And then these 2 pointers. The regions they occupy in memory are different. The locations of the memory regions they occupy are different. Obviously, if you place it in the memory region of the first map and place it in the memory region of the second map, they definitely won't be the same. But the objects they point to are the same. You need to understand, meaning we can compare it like this. Whether this pointer is exactly equal to this pointer. We can take a look. The objects they point to are the same. Of course, in this case, it should be okay. B. EQ. Just a moment. Run click. Back. Okay, let's see what the result of its execution is. Likewise, let's supplement another one below. Okay, our pointer's arrived. We'll let him go directly into this actor of ours. Okay, let's go down. Okay, this place is empty, right? Okay, add 3 objects. These 3 objects, you can see that the values of these 3 objects are like this. Then we try to perform a copy. So this is it, right? You can see that it looks like this, right? Then we make a check. Oh, it seems this part is written incorrectly. This part needs to be written as taking 1. Excuse me? Let's start over. Okay. We're coming back in now. Right, what I just wrote was incorrect, because the previous one was clearly, some things just appeared. It's equivalent to what we call, in the number set, we call it out of bounds, right? Then, for TMap, it actually means that this object was not found, meaning later, if there is an issue, it will crash. And in this spot, we actually set the same actor. Yep, since it is true, then we carefully observe these 2 maps. You will notice that this pointer that points, as you can see, the object it points to is an actor, and actually the object pointed to in this map is also an actor. Actually, if I if you clear out the contents of this area, it won't affect your host pointer. Then actually, when we talk about the actor lifecycle, if you haven't attached uparity, then your host, it won't affect this actor. This lifecycle, if you attach uparity, then it is equivalent to, it will record that this actor was referenced, things that can't be recovered or anything like that, right? Maybe this area is a little rough. Actually, if we have time to circle around a bit more for everyone, circle around a little more, it's fine. Let's expand it a little. Otherwise, if we only discuss this, it's actually quite simple. So we can also create a self-referencing pointer. As for the self-referencing pointer, it's actually like this. We have one, that is, we have the data structure of a struct, and then we have two self-referencing pointers pointing to it. Then only all self-pointers pointing to this object are recovered. Only then will this object be truly released. So what is placed here is a smart pointer like this TSharedPtr. That means you need to pay attention. Oh, she is very special. What is most special in our engine is this, the core of the engine's UObject. Because AX is actually its negative class, it is also a UObject. The way UObjects work internally is very special. There is also the method of using smart pointers. That is also very special. We need to discuss smart pointers separately. The result should not be placed here. Okay, thank you everyone.